Thank you very much for inviting me today. My name's John Hustler and I'm from DEFRA. I work in the Agri-Food Chain Directorate in the Innovation, Productivity and Science team. Daniel mentioned earlier that there's a perception that policymakers down in London thinking, what on earth is anyone going to do with 5G? Well, I think actually we perceive it as a really key enabler for many things. So it isn't forgotten. It's still there. In DEFRA currently there's no plans around 5G, but we will be working with other government departments when we're delivering policies around innovation and data in the future. And sort of two of our key areas of policy at the moment are research and development and innovation, and skills and knowledge exchange, and developing policies around benchmarking. So data obviously is key to this, and 5G is seen as vital to the movement of data and enabling the innovations. So first in this session we've got Stephen Leese from Precision Decisions, who deliver productivity improvements through smart agriculture.
Very, very briefly, the story, well, you've heard a lot just in the previous session about technology and 60 gigahertz and all this sort of stuff, which is great, but honestly it's a bit boring, isn't it? So what we really tried to do in the project is to show what you can do once you have the technology. What can it be used for? I think that's, if we're talking about trying to gather investment into rural areas, and we heard earlier on, actually if you really looked at it from an economic perspective, it doesn't add up. You will not get an M&O to invest in rural areas, simply not enough people to sign up for their services. So there's got to be other things that you can do in rural areas to get people interested in putting this technology in place. And we tried to look at that. Obviously agriculture is one of them. Agriculture by definition takes place in rural areas still currently. And we've looked at ways of improving productivity for farmers using this technology, mainly around precision agriculture, using the technology to apply fertilizer, to apply agrochemicals in a more precise manner. You might apply the same amount across a field, but you apply it precisely where it's required, and that has an environmental and a profit aspect for the farmer as well. This is what we did, our first use case. I'll talk through 3 use cases, one on arable, one on sheep, and another one that developed out of these 2. The first one was about arable productivity. Now what you can see here on the screen is on the top left-hand corner there is a field recently been planted. That's what it looks like to the naked eye. It looks nice and green, and it does not look very variable. But if you go up with a drone and take an image, as you see down here, with a multispectral camera, that special imagery in the near-infrared band can show you variability in the field that we would not be able to see if we stood alongside it, as you can see in that other picture. So we had Blue Bear using the drone, as you can see there, what we call the LEMSIP drone, for obvious reasons, taking images of the field as it grew. And part of the project report is we're going to create a report called A Year in the Life of a Crop, where we will show specific decision points that farmers have to make about 4 or 5 times during the life of a crop, where they need this type of variability information to make the best decision. And to do so, as you can imagine, what we need is a good communication network in field to be able to transfer this amount of data in real time. And that's where the 5G network comes into play. We worked out that by doing this, there is up to about a £700 per hectare benefit to farmers if they apply their inputs variably and more optimally, depending on what the crop is and so on and so forth. But it can be, in arable terms, a significant profit margin boost if they do it this way. The next one, I take great delight in going down to London and talking to the people down there and saying, when they ask me the question, what are you spending all this thousands of pounds worth of money on with 5G? And I say, we're counting sheep. And actually was on the radio saying that too, and they said, well, doesn't that put people to sleep? And hopefully it doesn't, but you may think, why are we counting sheep? Well, what we've done here up on the North Pennines is enabled a farmer to go out and count his sheep using the drone. Now, when talking to the farmers, I think it was interesting talking with Catherine about engaging the local community. You talk to the local farmers, I think what we didn't realize is they go out every single day and count their sheep, even on the fells where it's very extensive. So they have to go out and they have to know exactly where their sheep are. And it takes 2 to 3 hours a day to do so. Now, if we can do that with a drone, and we used Kingston University, Hamideh is here and has been showing you the algorithm they use so that they can differentiate sheep from rocks, and we can count those sheep, then I can give him the number of sheep and the location of the sheep in an instant while he's having breakfast. Now you may think, so where's the advantage of that? Because it's the same information. But it gives him 2 or 3 hours extra time during the day to either do other things or to supplement his farm income doing non-farm work, like building kitchens or whatever it is they do to supplement their relatively low farm incomes in these areas. And that is the actual use case. And I think there's a lot of that in this technology, that the use case is not direct, it's more indirect. So the direct use case here is counting sheep, but the benefit is indirect in what he can do with the extra time that we enable him to have as a result of using the technology in this way. One thing that came out of this, we put these 2 use cases to a group of our farmers as a sort of mini research project, market research project. And they said, yeah, Stephen, these are okay, but they're not that compelling. And what they said to us was, what we really want, just give us the connectivity and we'll work out the use case. Don't you worry about the use cases, just give us connectivity. And that made us think a bit wider about what happens in rural areas if there is no connectivity. And we came up with quite a few other things outside of agriculture, which actually towards the end of the project became very, very interesting. So a few facts about the rural areas. One is there's poor communication, as you know, as we've talked about. 2, there is increased automation. So as you go around and driving around and you see those straight lines in fields where the fields have been planted, they're not done by humans anymore because nobody can drive that straight. It's all done by satellite-driven automation. So the amount of automation in farming is terrific and very significant at the moment. A lot of people talk about self-driving cars from Google and Apple and so on. There have been self-driving tractors for over 25 years. So agriculture has always been at the advance of new technologies. And this is another one. The third point there is there a significantly declining workforce in agriculture. So whereas 25 years ago on a 1,000-hectare farm you may have a team of 10 or 12 people running it, today that's 1 person, maybe 2. And if you combine those 2 things, increased automation and the decrease in the workforce, that means the people working the land nowadays are working alone for long periods of time. They have isolation. They are working in isolation. They can't even be contacted by their loved ones, their children, whomever. So there's no connectivity, there's no contact during the day, a long day. And that can lead to all sorts of health issues, including mental health issues, which was the use case, I think, which we were surprised about that developed from the work that we were doing. That increased isolation can indeed lead to all sorts of issues. And by chance, earlier on this year in February, a report was published showing that 1 worker per week in agriculture takes their own life. And if you think about that and you combine that with the low farm incomes that there are and the pressures farmers have, combined, by the way, with the ability and the opportunity farmers have, there are all sorts of things on farms that will kill you. So it's easier for them to get into a situation where they may think that there's an easier way out. And this area has developed into quite a significant area. Loneliness and mental health. And I know, as we're talking with Antonia, DCMS are also looking at this in particular about how connectivity in rural areas can alleviate this loneliness aspect. But then it goes even further than that. And we talked about banks closing, post offices closing, and so on. That means the rural infrastructure, the basic fabric of a community in a rural area is disappearing. Pubs are even closing. Post offices are going. The very people who are not that well connected through the internet are losing their public services that they require. And then they have to take maybe a rural bus or a car into a town to get those services with all the associated congestion problems that go along with that. So we're thinking that if we can show through connectivity, we can maybe potentially rebuild the fabric of a rural community. You can encourage young families with children to stay in the local area. That might help justify keeping the school open in the area. That might help justify keeping the post office open in that rural area, and so on and so forth. There's a knock-on effect which we think may all be the catalyst for all this, could well be enhanced communication. That's all I'm going to say on that. Basically, the story I've got to tell as a story is we started off looking at wheat and sheep, and we ended up looking at the rural fabric and the community in rural areas. And I think that was the main learning from this project, how we went from one end to the other in 18 months. Thank you.
Hello everyone, my name is Hamideh. I'm a postdoctoral researcher at Kingston University working on the computer vision part of the 5-grid project. The aim of computer vision part of the project is to facilitate development of smart farming applications such as crop monitoring and livestock monitoring. The first use case that was investigated by Kingston University is crop monitoring. Our goal was to develop a system capable of crop monitoring and classification of crop from weed using multispectral aerial imagery captured by UAV using from farmlands. And then advanced computer vision techniques such as deep learning is applied on the data to classify and segment them as plant or weed. This picture shows qualitative results on some sample images. As you can see, the probability of each class is mapped to red, green, and black color representing weed, crop, and background. And the overall accuracy of our system for classification crop from weed is about 87%. That's a very good accuracy considering the challenging task of crop weed classification. The second use case that was investigated by Kingston University is livestock monitoring. The aim of this use case was to develop an efficient and remote livestock monitoring to understand livestock distribution across the farm using advanced computer vision techniques. However, one of the main challenges in this use case is detection of small objects. In drone images, small objects are livestock, which are very difficult to detect, and AI technologies like deep learning algorithms show very poor detection for them. And then we improved our computer vision algorithm to achieve better accuracy for livestock detection, and gradually our accuracy increased from 55% at the start to approximately 85%, which is quite good accuracy for small object detection. And these are some sample results of our algorithm that could detect the sheep, as you can see in this image, with a red bounding box around them. And as you can see, most of them have been detected by our algorithm, as I said, with about 85% accuracy. And this was from my side. Thank you for listening.